Good morning to one and all. In the previous video, we have discussed about some of the factors which will affect the economics of power generation and some of the factors which are really impact the power generation as well as the cost of power generation. In this video, we are going to discuss about some of the problems regarding to those factors. The first problem is a generating station has maximum demand of 25 megawatts, and 25 megawatts, a load factor of 60%, a plant capacity factor of 50%, and plant use factor of 72%. Find the reserve capacity. Actually, from maximum demand and load factor, we can derive the number of daily energy produced or number of units generated in a day. And formula for reserve capacity is plant capacity minus maximum demand. Maximum demand is already given. We need to find plant capacity first to find and reserve capacity of the plant. And third question is maximum energy that could be produced daily if the plant while running as per schedule or fully loaded. First thing is load factor is equal to average demand by maximum demand. That is equal to load factor is already given 0.6. That is equal to average demand divided by 25. That gives you average demand is equal to 25 into 0.6. That is 15 megawatts. And plant capacity factor is equal to average demand divided by plant capacity. Plant capacity is equal to average demand by plant capacity factor. That gives you 30 megawatts. Or otherwise, sometimes you can say plant capacity factor is equal to number of units generated divided by number of units that could be generated, or plant capacity into average demand by plant capacity into number of hours of use. Anywhere in the both the ways we can find the plant capacity. Therefore, plant capacity is equal to 30 megawatts and maximum demand is 25 megawatts. Therefore, reserve capacity of the plant is equal to plant capacity 30 megawatts minus 25 megawatts. That is equal to 5 megawatts. That's what it has given in the slide. And daily energy produced, I already told to you, number of units produced in a day is equal to maximum demand into load factor into number of hours in a day, or otherwise average demand. Already we found out from previous formula, average demand into 24. That gives you daily energy produced. And third one is maximum energy that could be produced. So maximum for plant use factor is given. Plant use factor is equal to number of units generated divided by plant capacity into number of hours of use of plant. That also he has given maximum energy that could be produced daily if the plant while running as per schedule. He has asked. So number of hours of use we have to include. That's what here plant use factor I am using. Otherwise, you can use plant capacity factor for finding maximum energy that could be produced. So here plant use factor is equal to number of units generated divided by plant capacity into number of hours of use. Here actual energy, maximum energy that will produce is equal to finally 360 divided by 0.72, that is equal to 500 megawatt hours per day. In the second problem, a power station has the following load cycle. Load cycle is given and it is time and load. Load curve is always drawn between time and load. 0 to 6 hours, the load is 40. 6 to 10 hours, the load is 50. 10 to 12 hours, the load is 60. 12 to 16 hours, load is 50. 16 to 20 hours, load is 70. 20 to 24 hours, load is 40. Draw the load curve according to based on between the curve is drawn between time and time on x-axis and y-axis megawatts. If you draw the load curve, it will show you the maximum demand. Whatever the data you can grasp from load curve. Here, after drawing load curve, the first question is maximum demand. Without drawing the load curve itself, directly by seeing the given data, we can say maximum demand is 70 megawatts. Directly we can say. And units generated in a load curve. From load curve, how we can find units generated? Area under the load curve itself gives number of units generated per day, because the x-axis is time, y-axis is megawatts. Megawatts into hours under the load curve, area under the load curve. Megawatt hours, which is, we can convert it to kilowatt hours, which is equal to units, which is units generated per day gives. And the average load out of the total area under the curve divided by 24 gives you average load, as well as load factor. Load factor means maximum demand divided by the average demand divided by maximum demand. Average demand already we got it from units generated per day divided by 24. And maximum demand is, we already got what is the peak value of load curve. Peak value itself gives a maximum demand. So in this problem, we need to first, he has asked to, given data is asked us to draw load curve first. So load curve is drawn for the given data, 0 to 2 hours, 0 to 6 hours, given 40 megawatts. So 40 megawatts we have drawn here, and 6 to 10, 6 to 10, 6 to 10. What is the value given? 50. So for 50 we have given, we have drawn. So finally, the peak of the load curve is 70 megawatts here. It is clearly showing that 70 megawatts. So therefore, maximum demand of the load curve, maximum demand on the station is always the peak point of load curve. Here the peak point of load curve is this one. So it is 70 megawatts. And second question is, units generated per day is area under the load curve. Area under the load curve is equal to, I need to find this area, this area. So subparts I am dividing, and I am adding all those areas will gives you area under the load curve. From 0 to 6 hours, that means 6 hours into, its value is 40 megawatts. 6 into 40 plus this area. 6 to 10 means 4 hours, means 4 into 50. This one is 10 to 12 means 2 hours. 2 hours into 60. In the same way, total part of the load curve we need to find area. So total area is there in megawatt hours. So for example, if I multiply it by 10 power 3, it gives you kilowatt hours. That's what he did here. Into 10 power 3 multiplied. Therefore, 10 power, it is converted to kilowatt hours, which is equal to units. 40 into 6, 50 into 4, what I said by showing the graph. 60 into 2, 50 into 4, plus 70 into 4, plus 40 into 4. This gives you units generated per day. And I already told to you, units generated per day is equal to number of, this is the what units generated per day. And the average load is equal to number of units generated per day divided by 24 hours. Therefore, number of average load is equal to units generated per day, 12 into 10 power 5 divided by 24 gives you average load. And last one is load factor. Load factor is equal to average load by maximum demand. Maximum demand already we got from a graph, as well as average load is also we derived. Therefore, average load is 50,000 divided by 70 megawatts gives you a load factor. Load factor is always, it is less than 1. So it is 0.714. That is equal to 71.4%. Same way you can do any problem related to load curves. And next one, a power station has to meet the following demand. Group A, 200 kilowatts between, there are 4 consumers. Group A, Group B, Group C, Group D, they are divided into 4 groups. And first group, it is having, they are having, or otherwise number of consumers connected to Group A comes under one group. Group A, 200 kilowatts between 8 a.m. and 6 p.m. Group B, 100 kilowatts between 6 a.m. and 10 a.m. Group C, 50 kilowatts between 6 a.m. and 10 a.m. Group D, 10 kilowatts between 10 a.m. and 6 a.m., 6 p.m. and then between 6 p.m. and 6 a.m. So before going to draw the load curve, we need to, in a perfect way, we need to identify what are the loads are there between 0 to 24 hours. After drawing also, we need to check, cross check again, because it's very, very important to draw a load curve here. First thing is, I am reframing the data like this. Group A is having 0 to, I am dividing into 5 slots. Here 0 to 6, 6 to 8, 8 to 10, 10 to 18, 18 to 24 hours. I am dividing. 0 to 6 means night 12 to morning 6. 6 a.m. to 8 a.m., 8 a.m. to 10 a.m., 10 a.m. to 6 p.m., 16 to 18 means 6 p.m., 6 p.m. to night 12. So I have divided it into 5 categories. Based on your flexibility, you can divide, and you can note the loads, total loads. Here, during 0 to 6 hours, night 12 to morning 6, what are the loads present here? You see, this is not present during that slot. This is not present that slot. This is not present during that slot. And this 10 a.m. to 6 p.m. is not present in that slot. And between 6 p.m. to and evening 6 p.m. to morning 6 a.m. Therefore, between 12 to 6, 12 midnight to 6 a.m. definitely this load is there. Therefore, out of these 4 categories, Group D is only there between 0 to 6. So I have to mention here 100 kilowatts. In the next category of 6 to 8 p.m., this is not there. This is there. Therefore, I have to mention here and this is there 6 a.m. to 8 a.m. means it is there in the slot, so I have to mention here. This is not there, therefore I'm not mentioning here. In the same way, 8 to 10, 8 to 10 means morning 8 a.m. to 10 a.m. This is there, this is also there, this is also there, and this is not there between that slot. Therefore, I have filled first three things. And 10 to 18 means morning 10 a.m. to evening 6 p.m. 10 a.m. to 6 p.m. means this is there, this is not there, this is not there, this is there between that slot. In the same way, 18 to 24 hours, we need to verify. These three are not there between that slot, uh, and this is there. Therefore, I have mentioned here what are the loads between those slots present. So total load between 0 to 6 is 100 kilowatts. In the same way, 6 to 8, what are the total loads, total demand of the station? Is between A, B, C, D, who are there, we have to mention. Here, 150 kilowatts is there between 6 to 8. In the same way, 8 to 10, we have 350, 10 to 18, 300, 10, 18 to 24, 100 megawatts, 100 kilowatts. We need to draw here. He has asked us to draw a plot a daily load curve. So if you have this information, you can easily draw load curve between time and kilowatt hour demand. Here time in hours 0 to 24 is given, as well as 0 to some megawatts is some kilowatts. We can draw the graph here. Between 0 to 6, what is the load? 100 kilowatts. Therefore, it is 100 kilowatts between 0 to 6 hours. So this is 6. You think it is an 6, 4, 5, 6. You think it is an 6 between 6 and 6 to 8. What is the load? 150. He has mentioned. In the same way, we need to continue for further information, and we have to draw the load curve. And finally, what is the peak point? Key point here is maximum demand is 350. Therefore, maximum demand on power station is 350. Number of units generated is area under the load curve. What we discussed in the last problem. The same way we have to continue, and we need to find area under the load curve. That gives you units generated. It is a very easy process. And what is the next problem? Load factor. Load factor is maximum demand. I already told you. Average load means number of units generated divided by 24 gives you average load. Therefore, average load by maximum demand gives you a load factor. So only thing is diversity factor is remained. What is diversity factor? Sum of individual maximum demands. Sum of individual maximum demands means there are 4 consumers and their maximum demands are 200 kilowatts, 100 kilowatts, 50 kilowatts, and 100 kilowatts. These are all maximum demands of individual customers. So sum of individual maximum demand of sum of individual maximum demands are 200 kilowatts plus 100 kilowatts plus 50 kilowatts plus 100 kilowatts divided by maximum. Maximum demand is 350. That gives you diversity factor. You see, maximum demand is 350 kilowatts, what I said to you. And sum of individual maximum demands of groups are 200, 100, 50, and 100. That gives you 450 kilowatts. Diversity factor is over sum of individual maximum demands. What I said to you is for 450 divided by maximum demand of station is 350. That gives you 1.286. And second one is units generated is area under the load curve. 100 into 6 plus 150 into 2. Total area is 4,600. In the previous problem, what we did is into 10 power 3 we did. That is because the data is given in, the load is given in megawatts. But here in this problem, it has given the load in kilowatts. So directly we can multiply, we can find the area of each block, and we can find number of units generated per day. And the average load is total the number of units generated divided by 24 hours. That is equal to 191.7 kilowatts. That is equal to average load factor is equal to, and also average load factor is equal to 191.7. And that means the average load divided by maximum demand is 350. That gives you 54.8%. Thank you. Thank you very much.